Now, in this session, we will try to understand how to calculate rate of reaction from a data of concentration and time. Now, even though the discussion will be limited for calculating the rate of reaction from data of concentration versus time, but the same method can be used if in place of concentration the value of partial pressure and time is known to us. Now, how to do it? Let us try to understand. So, suppose we are carrying out certain reaction where the reactant A is fed and the sample is determined sample is taken out at various time interval and it is analyzed. So when the sample is taken out at various time interval and whenever it is analyzed, then we get the data of time versus concentration. Or say when time t is equal to 0, that means when the reaction is not yet started, whatever the concentration of reactant is there, that is considered as CA0. CA0 stands for initial concentration of the reactant. Then say you have measured or you have taken out sample at time t is equal to T1, the concentration is Ca. At time t is equal to T2, concentration is Ca3. Say at time t is equal to T3, this is Ca2 and concentration is Ca3. And likewise, say this is the final time and correspondingly the value of the reactant concentration measured at time t is equal to say Ca. Now, if you plot the graph, then the nature of the graph will be like decay curve. So at time t is equal to 0, so x-axis is time and y-axis represent say concentration. So at time t is equal to 0, the concentration will be Ca0. Now, initially, the rate of reaction is higher, so the concentration will fall rapidly. Say, this is the point where the first sample was taken out and corresponding time is say T1. Then say next sample was taken out at time T2 and corresponding concentration is Ca2. Likewise, Ca3 and corresponding concentration is T3. So say next is this. Like this. Now you will realize, say this is 0.1, say this is 0.2, say this is third sample, say this is 4, this is 5, fifth, etc., etc. So after fifth sample, you may observe that the change in concentration is not significant. Rather, thereafter, if even if you continue the reaction for infinite time, the concentration will not change. So say we have given some, we have carried out reaction for sufficient time. Say in order to ensure the complete reaction, say this is time t, and corresponding concentration is say C. Now, whenever we observe this type of the behavior, we say that the reaction is over. We say that the reaction is over. Actually, if the reaction is over, the reaction concentration should have been zero, but it is not the case. See, when we say that the reaction is over, it means that whatever the maximum possible conversion was expected as per the thermodynamic limit at that condition, that has been that is obtained. So after that, even if you carry out the reaction for infinite time, it will not change. So the reaction is stopped, and we say that the reaction is over. Once again, I am repeating, the reaction is over. It doesn't mean that the conversion is 100%. Now let us try to connect the point. So the nature of the curve is like a decay curve. You can see initially the drop in concentration, that means the difference in the value of Ca0 and Ca1 is quite large. But as the time progresses, suppose if I take this fourth point, the this concentration will be Ca4. So the difference between Ca3 and Ca4 is less. If I take fifth point, the difference between Ca4 and Ca5 will be less. It indicates that the rate of reaction is decreasing. It indicates that the rate of reaction is decreasing. And after certain time, you find that there is no significant change in concentration of reactant with respect to time. What does it mean? For every reaction, there is a maximum possible conversion which can occur, that is decided by the thermodynamic limit. And if that conversion is occurred, then we say that the reaction is over, but it doesn't mean many a times that the reaction is 100%. Okay. Now, so these points, so the data of time, the sample, the reaction was carried out, the sample was taken out at various time interval, and now the data of time and Ca was available. That was plotted, and the points are connected. Now the question is, what is the use of this, and how to use this for calculating the rate of reaction as it was discussed, right? So for calculating the rate of reaction, what you have to do is select the point. So say I have selected point number 1. Then next is, since it is a curve, what you have to do is you have to draw a tangent to this. You have to draw a tangent and try to calculate the slope of this. Say, suppose if this is Ca1 dash, concentration corresponding to this, and concentration corresponding to this is say Ca double dash. Likewise, you can also note down the corresponding time. So I can say that time is T1 dash, and corresponding time will be say t1 double dash, like this. Now slope of the tangent, slope of the tangent, the slope of the tangent is y2 minus y1 divided by t2 minus t1. So y2 is ca, say 1 double dash, y1 is say ca1 single dash divided by t1 double dash minus t1 single dash. Now this slope is known as change in concentration per unit change in time. So it is, and since we are referring to the rate, it is minus Ra. But please remember, this concentration 2 y2 will be less than concentration ca1 dash. So this will be negative. This will be negative. So as I have told you that rate may decrease, but its value will not be negative. And therefore, what I will do is I will multiply this by minus sign, and what I will get is ca1 dash minus ca double dash, because I have multiplied by minus sign, t1 double dash minus t1 single dash. Because of negative sign, just there is the change in the position of these concentration terms, and now this will be positive. So corresponding to the point 1, I have determined the slope, which is representing dCA by dt, and this dCA by dt is equal to rate of reaction. And since it is corresponding to the point 1, I may denote it as a minus Ra2. Likewise, suppose if I am interested in finding the slope at the point number 3, so what I have to do is I have to draw a tangent to the point number 3, and then again calculate the slope. So on the same line, minus Ra3 will be equal to, if you use the analogous thing, then ca3 single dash minus ca3 double dash divided by t3 double dash minus t3 single dash. So in this way, for every point, you have to draw the tangent, you have to draw the tangent, and that slope of the tangent will corresponds to the rate of reaction at that point. So at time t is equal to t1, the tangent was drawn. So the slope corresponding to this is equal to rate of reaction at point number 1. At point 2, t2, if the tangent is drawn and if the slope is determined, that will correspond to minus Ra2. If at point 3 the tangent is drawn and the slope of the tangent is equal to minus Ra3, like this. Many a times I have given you an example, an analogous example, that initially the rate or the fall in concentration is very large, but it progressively decreases with respect to time. As an analogous example, I always explain that on the day of salary and few days after, the rate of expenditure is very large, but as the month end, the rate of expenditure decreases, and there is always a reserve fund which is kept in a family for emergency. So if you ask for a money, then your parents may say no, money is over. Does it mean that they have 0 rupees? No, they have kept it as a reserve. Likewise, and initially you must have seen in the first week the rate of expenditure is more, in a second week the rate of expenditure is less, in a third week it is still less, like this, right? So in case of the rate of reaction, there is the maximum possible limit set by the thermodynamics, that what might be the maximum possible conversion at that particular temperature. Thereafter, so if that conversion is achieved, so even if you carry out the reaction for infinite time, it will not change. It will not change. And then we say that the reaction is over. Now you have studied ammonia manufacturing, and if I'm not wrong, somewhere around 17% conversion is mentioned in the manufacturing process. Actually, we should have obtained 100% conversion, but still we are accepting 17% because of some limits. Because of some limits, we are also okay with that particular 17% conversion. On the same line, whenever we carry out any reaction at a different time interval, we take out sample, we do the analysis. From the analysis, we can understand the value of concentration of reactant at different time. Then the plot of concentration versus time is made, with concentration as y coordinate and time as on a x axis. The plot is made, the nature of the curve, the nature of that smooth curve is like a decay curve. And for calculating the rate of reaction, the tangent is drawn at the point or at the time where the rate of reaction is to be determined. Now, just for the sake of your understanding, I would like to tell you. Now, suppose if I consider this point, and if I draw a tangent, then the slope will be very less. Now, slope represent the change in concentration, and this vertical line represent the change in concentration, and this horizontal distance represent change in time. So you can see now change in concentration is much less compared to the time, whereas in this case initially the change in concentration was very large, but the time less. Similar thing was observed over here. And if you plot if you draw the tangent, it will be simply flat. It means that the value of dy will be 0 and value of dt can be infinite. So when we say that it is 0, so the value of rate is 0 because the reactant is not get consumed. We will be able to calculate the rate of reaction only if the concentration of reactant is changing. That means if the reactant is getting consumed. If it does not get consumed, then there will not be any change in concentration of reactant with respect to time, and therefore we will not be able to determine the rate of reaction, rather it will be 0. So I hope in today's discussion you must have seen how the rate of reaction is determined by using the experimental data of concentration versus time. Now please remember, I am just warning you about the possible mistakes some students who don't know the basics makes. Some people's whenever the rate is to be determined and when the nature of the graph is curve, the slope, for determining the slope you must always draw the tangent at a particular point, and the slope of tangent at that point will correspond to rate. So you will see that the slope is changing, that means rate is changing. But suppose if you consider just the graph, the straight line, so whether you determine slope here or here or here, it doesn't make any difference. Why? Because slope is constant, and therefore the slope of straight line is always constant, but slope of curve always changes. So suppose if some students Try to do it like this: Ca0 minus Ca1 divided by T1 minus 0, then Ca2 minus Ca1 divided by T2 minus T1. Then they will be making mistake because they are trying to assume as if it is a straight line, which is not the case. So for calculating the rate of reaction, the graphical method is the only option. You have to plot the graph of concentration versus time at a different point, draw the tangent and determine the slope of the tangent at that point. So slope of the tangent at that point is equal to rate of reaction, and this data of rate concentration is used for determination of complete rate expression. I'm very sure that you must have understood exactly how the rate of reaction is calculated by using the experimental data by graphical method. Thank you.